Swayam Prabha. Digital India. Educated India.
In this lecture today, I am going to discuss on gearbox fault detection. As you know, gearbox is a very important machinery component which is there in almost all plants. Particularly, gearboxes are used for speed reduction and of course, power transmission with the reduced speed. Many operations in a plant are at very slow speeds, and typical the prime movers in any industry are typically the electrical motors, as you all know. And electrical motors invariably run at a constant speed, maybe at the just little less than the synchronous speed. It could be 2 pole, it's around 3000, 4 pole around 1500 at little less, 1440 RPM or so on. And but there are many operations where the plant needs to run at 3 RPMs, gearboxes in lathe machines which run at various speeds. So, there is a requirement of speed reduction and power transmission. And of course, power transmission, which is nothing but the torque times the rotational speed. So, essentially gearboxes are used to transmit power by playing with these parameters, changing rotational speed and torque for a given power. Now, another important feature of this gearbox is the direction of power transmission. For example, we have a shaft which is rotating. I suddenly want power in a direction 90 degrees to it. So, obviously, I have to have some sort of an arrangement in the gears, so that this power can also be transmitted in an angle of 90 degrees to the incoming shaft. So, if you look at a gearbox, I have an input shaft and then I have an output shaft, and there are on these shafts there are gears mounted, and these shafts of course will not be in the air. So, they will be mounted on bearings and they are put on a casing. This shaft is also, maybe this is having another gear, and this is also another shaft, and which is put on a bearing here. This is just to demonstrate to you how a simple gearbox looks like. This is the casing. Casing. These are the bearings, and this is usually known as the pinion gear, pinion, and another gear. One fundamental principle in gearing is the number of teeth times the speed should be equal to number of teeth in the other gear and its speed. So, this is always obeyed. N is the rotational speed. Okay, this gear are basically, if I was to draw a gear file, of course, I am not going to give you a lecture on gears, but essentially some of the important features of a gear. So, this is, if I just draw one tooth gear, okay, and then there will be such tooths all around the circumference of the, and this is the root of the gear tooth, this is the flank. So, as if, and this is going to mess with another gear, from the pinion and so on. And one gear goes this way, other gear goes this way. So, lot of things happen on this gear. So, there has to be a constant velocity, otherwise we would be getting jerky motion and so on, and there will be forces coming on to the flank, forces on the flank. So, there are a lot of metal to metal contacts between the gear tooth. So, for gear to be strong enough, this tooth is also behaving like a cantilever beam. Obviously, it is going to deflect each time it messes with a gear tooth from another gear. So, along the gearbox, this pinion is there, gear is there, and each time they are rotating, one tooth messes with its corresponding tooth from the other gear, and so on. This kind of gear meshing happens. Now, question is, when the gear tooth are in contact with the other gear tooth, there will be forces, and because of the contact there is friction, and so there will be wear, and there will be heat generation. So, lot of these things happen in the gearbox. This kind of mechanics happen in the gearbox. So, for some reason, if this gears are not able to sustain the heat generated because of the friction, not able to generate the forces, they are going to fail. I will come to this a little later, but now let me tell you what are the different types of gear available. So, this gear, depending on, if I look at the top view of a gear, these gears can be all straight, and these are usually known as the spur gear, or they could be at an angle, and these are known as the helical gear. But spur and helical gear are used to transmit power in the same direction, but whenever there is a power transmission in 90 degrees, we have what is known as a worm and a bevel mechanism. So, gears look something like this, and this is one shaft here and another shaft which is rotating in this direction. So, this is a bevel gear arrangement, and such gearboxes, such gears you will find in windmill, in automobile differentials, and of course, they all have to obey the law of gearing while they are in motion. Now, these gears are put in a casing I was just mentioning to you, and because we have to remove the heat which is being generated from the gearboxes because of the frictions, many things happen in the gears, and this will lead to the, if go unnoticed, they will lead to the failures of a gearbox. So, this is a typical automobile gearbox. I just wanted to show you what are the things which we have. See, for example, this one of them is an input shaft, other is the output shaft, and this is an intermediate shaft, because in an automobile gearbox we can bring about different types of speed reduction. This is a 4-speed gearbox, okay. And you see these kind of gears which are at an angle, they are all helical gears. This is one particular gear which is meshing. This is the counter shaft of the lathe shaft, and these are again the gears, and these are what are known as the synchronizers, which can be shifted while you shift your automobile gears, so that they will mesh, appropriate gears will mesh, and then we will get a speed reduction. And this is another gear, okay. So, in automobile gearbox, we have synchronizers, and I will show you how this defect can be, because see, each of these gears, this tooth will deflect under load, they will get heated up because of the friction. So, there is always these gearboxes are having in this casing some sort of a gear transmission oil, or a oil basically used for its lubrication, carry over the heat. And many of the automobile gearboxes, or in gearboxes per se, people also monitor the oil condition gear oil condition in terms of its temperature, because there should not be a case when the temperature of this oil has gone to a level where the physical and chemical properties of this lubricating oils are lost, the molecules, bonds, etc., break. Okay. And another is the presence of wear particles or wear and debris in the oil. Because what happens with time, when there's two teeth mess with each other, they rub against each other. Okay. Once they rub, because they may be soft, the proper heat treatment is not done, these particles may flake off and get deposited in the oil. So, a very important manufacturing requirement of gearbox is such that is the tooth are hardened. Okay. They are case hardened in the sense that the tooth are very hard to or wear resistant. So, many times what I have seen, if a proper heat treatment is not done on the gear tooth or on the gear on the top, these particles will flake off. And these particles will get deposited in the gear oil. So, to find out the defects in gearboxes, many techniques can be used, and which will come one by one. I will just show you another type of gearbox, and these are some of the defective gears. For example, this is some experiments which we are doing in the laboratory, wherein we could artificially seed faults in the gear by an wear EDM machine, because these are very hard, and normal milling operations you cannot perhaps cut this and remove the gear tooth. So, this is where we have removed 2 teeth, because we are trying to do some experiments on vibrations of the gearboxes because of such defects. So, we had to do it, and of course, they are so hard that we had to use wire EDM to cut the gear tooth. Now, the kind of faults which can happen is I will list them in the next slide and subsequent slides. So, this is how a healthy gear looks like, and this is what I meant by the flank, the land, the root, okay, and these are all helical gears, and we have removed them. What happens because of the change in the gear tooth, and mind you, when the 2 gears are messing against each other, okay, there is always a variation in the stiffness. By stiffness I mean, you can imagine, one gear making contact, one tooth making contact with one tooth, it would have left, and then the other tooth will come up. But imagine if suddenly one of them is absent. One of them is absent. So, what is going to happen? Momentarily, it is not going to withstand that resistance, or it is not going to have that resistance on it. So, this will lead to a change in its stiffness. Material is not there. Okay. So, this variation in stiffness leads to sudden change in the response or deflection, change in the deflection of the gear. So, these deflections will be responsible for creating a vibration. Okay. So, because a vibration has been generated because of a gearbox fault, we will see that the fault has occurred. Okay. So, one is the gear oil conditions in terms of its temperature and physical changes because of the wear debris particles. Other is the vibration in the gearbox, and this vibration is transmitted to the shafts which are mounted on bearings, and then which are conveyed to the casings, and on the casings we can mount our transducers or accelerometers. Okay. So, to detect gear faults, we can have so many conditions. Number 1 is the oil condition, other is the vibration. So, in oil conditions we have temperature and the debris. But interesting thing about the vibration is that in a gearbox there are bearings, there are gears. So, how do you know that the vibration is not because of the bearings and it is only because of the gears? That is the power of vibration signature analysis. That is, every mechanical component, its vibration is manifested at its characteristics frequencies. So, what are the characteristics frequencies of a gearbox? Of course, we know the fundamental characteristic defect frequencies of bearings, and in the earlier classes I had told you how to find out the defects in bearings because of the faults in the bearings, and you would have seen the frequencies of ball spin frequency, ball pass, inner frequency, outer frequency. Okay. So, these frequencies and their harmonics show up when there is a bearing fault, but when there is a gear fault, something known as the GMF, it is known as the gear meshing frequency will show up, and there will be side bands around the gear meshing frequency, because these gearboxes are subjected to change in load, change in speed. Okay. So, there will be momentarily modulation of this gears gear vibration because of these defects. So, there will be side bands around these gear meshing frequency because of modulation. So, any signal processing technique which can identify this, that is the gear meshing frequencies and the side bands around it, is good enough to find out the gearbox faults, but that calls for a detailed vibration signature analysis. Okay. So, how do we do that? We will come to that a little later, but let me continue on my discussions on the other types of gears. So, this is a planetary gearbox, okay, where inside it we have the gears which are worn, and this is how the gearbox is used in our fault simulator in the laboratory, where this is actually a motor driving the shaft, and to which we have the pulleys, which is the input shaft, and then this is the output shaft. At this end you will see a clutch device, a magnetic clutch, which is used to load the gearbox. This kind of gearbox is used in our lab for the studies, and this is actually a gearbox in a plant. And if you can see here, the white one is actually a big motor, okay, which is driving a multi-stage gearbox. It's a 3-stage gearbox, and there is an output shaft where we bring about the speed reduction in the speed, and this actually was used to drive a conveyor belt in a raw material handling plant. And this you will see the side glass for the oil which is kept inside the gearbox, and you will see some the oil is actually leaking from one of these drain plugs here, and these gearboxes are put on a foundation here, and then this is the gearbox base. Okay. And in fact, you will see a lot of corrosion occurring, and many times because of this corrosions, the gearboxes will lose their alignment, and then the bearings will get unnecessarily loaded because the heavy loads, and they will be rotating under load. So, you can imagine it is like a domino effect, one leads to the other. Poor manufacturing of the gearbox housing, poor foundation, harsh environments, these all lead to the misalignment of the gearbox base, which in turn will increase the load, because there are heavy bearings here. There are usually rolling element bearings at this location, and these bearings will be responsible for the loads on the unnecessary loads on the shaft here, and then there will be uneven wear. So, to find out the causes of gearbox faults, one is of course the excessive load, because these gears are designed to transmit a particular amount of torque. Okay. This is some N1, T1, N2, T2. Now, the torque which is being carried, of course, this is the number of teeth, not the torque here. So, GMF is equal to either N1 times T1, or which is also equal to N2 times T2. Okay. Gear meshing frequencies, of course, they have to be in the same units, okay, so that we get them in either in hertz or in RPM. If it is in hertz, if n is in RPM, then we have to divide it by 60. Then this will be in and N is in RPM, rotations per minute. So, because of excessive load, sometimes gearboxes are designed to carry a maximum load, because the root, the famous Lewis equation is used to find out the stresses at the root of the gear. Okay. In a gearbox design, those of you who do gear design use that. And because this is like a cantilever, there will be failures, and these are usually the root crack. And because excessive loads came onto the gearboxes. And another thing is, on this gearbox we will be having what is known as the fluctuating speed and torsional vibration. Okay. Lack of lubrication, if the particles are not lubricated and the heat is not being taken away by the lubricant, there will be a lot of heat generation. And many times there is a minimum oil level which has to be maintained. And in industries, there could be mistakes and people do not have the entire oil. Of course, in automobiles, we have that transmission oil which is almost there. And many times you must have, I will just tell you a story. See, in an automobile, there are few types of fluids which is used. One particularly for the engine lubrication, we call it as the oil, which is used in engine oil. Okay. And engine oil is exposed to much higher temperatures, because they are very close to the combustion taking place, and they lose out because of evaporation. We lose them. So, every maybe 5,000 kilometers we top up the lubricating oil, that is one. But the another one is the transmission oil. So, transmission oil are not at a temperature as high as the engine oil. So, the evaporation loss is less, and maybe we only check them after 50,000 kilometers. Okay. And this is what is known as the gear oil. Okay. That is of course, the purpose of both is the same, to lubricate and reduce the friction in the mating engine components and the mating gear components. But because these are at a lower temperature than the engine oil, we need not replace them or check their levels beyond 50,000 kilometers. Sometimes in some of the modern cars, where the transmission oil goes to even very high temperatures, they have what is known as a gear oil cooler. A small heat exchanger which is mounted next to the gear oil, so that it is cooled and put back in the system. Of course, the key idea here is that this temperature has to be monitored. Temperature has to be monitored in such gear oils. Now, I just we know about this wear debris analysis in gearboxes, and all these oils can be used to find out their particles in them, and the normal wear debris analysis routines can be followed, and there is a particular schedule which has to be followed, so that the oil analysis, gear oil analysis along with the wear debris is done. That is for the gearbox. But of course, a much quicker way is to monitor the vibration. and do some sort of an signal analysis. And then find out the fault in this gearbox. Okay. So, we will come how this signal analysis is done. So, the causes of gearbox faults are excessive load, fluctuating speed and torsional vibration, lack of lubrication, presence of foreign particles, manufacturing defects like improper heat treatment, so that the flank wear will increase. Many times in gearbox, I myself have seen a lot of impurities there in the gearbox, and particularly impurities like sand or silica particles will be very detrimental for such system. Okay. And how do we detect that? So, in a gearbox, the type of failures which can occur is because of the pitting of the gear flank, this is one tooth, okay, and the pitting could occur in some of these areas. There could be cracks, there could be the oil film, because there is always a thin layer of oil film here, thin layer of oil film. This is the root crack, this is the pitting. Of course, the bearing faults, debris fault detection, coupling faults and overheating, all this can occur. So, all this will lead to increase in the dynamic response or otherwise vibration of the gearbox. Okay. So, we can capture the vibration of the gearboxes, and then how do we capture the gearbox vibrations? Suppose I have a multi-stage gearbox from the outside, these are the bearing housings. So, I have the option, and these are on the bases of the gearbox. Usually, the good locations to put the transducers are at the bearing locations. Sometimes we put it on the base just to make sure, and just for reference we can put it in one casing. Of course, the highest signal to noise ratio will be obtained at the bearing location. Okay. Highest signal to noise ratio will be obtained at the bearing location. So, we have to be careful that we mount the accelerometer on the bearings, and they could be either uniaxial or triaxial. Okay. Now, once this vibration from the gearbox has been captured, we can do what is known as the signal analysis, and signal analysis can be done in many types. Of course, the very basic signal analysis one done does the time domain. In time domain, we can of course always estimate its parameters or relevant, estimate the features, and there are many features we can estimate from the gearbox time domain signals. One, of course, the RMS, the mean, okay, the kurtosis, skewness, etc. There are about, earlier we are told there are about 20 different features which we can find out, but and then of course we can always trend these features with time. Okay, and then this may be increasing with time, and there will be a level at which I will know this is an alarm point. Okay. But we would not like to measure only at such gross levels to only know whether a defect has occurred or not. However, to diagnose it, we have to do something further beyond just time domain feature estimation of the signals. However, it has been found in gearboxes which the time domain signals are greater than 6 kurtosis, we can say for sure that there is a fault in the system. Okay, for a faulty system there can be, but however to diagnose. So, there is a difference between fault detection and diagnosis. We know grossly this will let us know that there is a fault in the gearbox, but we would like to know which gear, how, where and so on, and then we have to go more into diagnosis module of the gearboxes. And there are many ISO standards which I will tell you in the case when we discuss about case studies in general and how such case studies are used to measure the vibration of systems. And of course, because we want to go into a fault diagnosis mode, we have to do what is known as we can go in the frequency domain mode by technique of FFT, and I will be seeing certain peaks, and then around them there will be sidebands, and this is the vibration level. So, the amplitude of sidebands will increase over time, and these sidebands are around the gear meshing frequencies and its multiple. But what happens many times, because there are a lot of other signals. So, these sidebands are very nicely buried in noise. So, the signal to noise ratio at sidebands is poor. So, we have to find out an improved signal processing technique to detect such sidebands, and that is what is known as the substrum analysis. We had an entire class on substrum analysis, and there also I believe I had covered about the gearbox signal fault detection. I will give you some examples. But another important thing which happens because of these defects in the gear tooth, there will be a lot of impacts occurring, and these impacts in the time domain will look something like this. So, this kind of they are highly non-stationary signals, because they are not definitely existing at all times, they are not periodic. So, the fundamental signal processing theorems of stationary signals, wherein the properties of the single ensemble over a given time change is being violated, and thus stationary signal analysis like FFT etc., cannot be done on such signals. So, we have to do signal analysis using certain non-stationary signals like the wavelets. Okay. Wavelets, and then things like short time Fourier transform or STFT. So, some of the advanced diagnostics software which are available have these features by which we can do such signal analysis. Okay. Now, I will give you a case study for a signal which we had done in the signal analysis in the laboratory. I will just give you a relative feel of this is a normal gearbox frequency, okay. And then you will see about from 0 to 1000 in the gearbox which I had showed in the laboratory simulator, and this is the amplitude of the vibration measured at the bearing location, okay, or sometimes in the gearbox casing. You will see this gear sidebands around the gearbox frequencies, and these are characteristics of the gearbox signals. You will realize that whenever we have seen the signals of the other mechanical systems, we will not see such sidebands around GMF, and that is the characteristics of a gearbox vibration signal. And to find out more about the sidebands, we have to use the technique of subsystem analysis. So, just to quickly recap, I did tell you about the gearbox debris analysis, debris and oil analysis. I mean, the gearbox oil will lose its property, the debris will be deposited. Looking at the debris, we can get some clue. Next is vibration. Of course, another technique which we in our group at IIT Kharagpur have successfully used is this MCSA motor current signature analysis. Okay. And this has been used to find out gearbox fault. I will tell you briefly what is there in this. Suppose I have a motor here, an electrical motor through a coupling. It is driving a gearbox, and this motor, there are current which is being drawn by the motor. So, what happens is there is a defect in the gearbox. This gives rise to some sort of a load, additional load torque on the motor. So, if this motor is being subjected to an additional load torque, the current itself gets modulated at the frequency of the occurrence of this defect. And so, the sidebands in the current will also indicate some presence of the mechanical defects. Okay. So, sidebands around the supply, I mean the electrical supply frequency of the motor current will indicate a mechanical fault. So, this we have successfully used to demonstrate gearbox fault, and more details about this can be found again at my website, and you can refer to some papers in journals like MSSP or JSV, Mechanical Systems and Signal Processing, or Journal of Swayam Prabha, my publications, and then you will see that how these motor current signature analysis has been used to find out gearbox faults in the laboratory. Now, when we had a one gear case, okay, the amplitude, there is a change in the amplitude. In this case, showing you a comparison, actually the amplitudes are from a different gearbox though. So, that is why it is not fair to compare between the first graph and this graph, but then there is a difference in the spectrum. But what I wanted to show you here is that the gearbox side bands around the GMF have to be found out by the system analysis, and the system analysis of the gearbox signals, this is in dB, they will give you certain Q frequencies. So, the inverse Q frequency will be related to the rotational speed of the pinion or the gear, or there are multiple. In this case, there is a strong multiple. So, you will see which one is more at fault. Just for the sake of discussion, suppose this is running at 600 RPM and this has 20 teeth and this has maybe 10 teeth. The speed at which the gear, N gear, is nothing but 600 times 20 by 10 is about 1200 RPM. Okay. So, one rotates at 600 RPM, other rotates at 1200 RPM, and the inverse time period would be. So, this is 600 RPM will correspond to 600 by 60, that is 10 hertz. So, the time period is 1 by 10, that is 0.1 second is for this one, and for this one it will be just twice. So, this will be the time period of G will be 0.2 seconds. Okay, this is going at a much slower speed. Is that right? I done a mistake here. I believe this will be at a slower speed, isn't it? Okay, I have taken this as 10. Maybe I have drawn it wrong. This is the other way. But anyway, if the number of teeth here is 10, that's okay. So, this is rotating at 0.2 seconds. So, in the Q frequency, and some dB amplitude, because this is in a log scale, if I see a Q frequency at 0.1 seconds or 0.2 seconds, I know at a particular, and with time if I monitor the Q frequencies, I will know that there is a fault in the device which is running at with a time period of 0.2 seconds, the fault in a component which is running at 0.2 seconds. In this case, it is my gear. Okay. Okay. So, we can use such a technique, system analysis, to find out, pinpoint the fault in a particular component. So, just to summarize, in gearbox, it is a very important mechanical component, and this component or this device is used almost in every industry. So, two broad ways of fault detection in gearbox is, one is doing the either the oil analysis and the wear debris analysis, another being the vibration analysis. And vibration analysis itself can be done in many ways, just in time domain signal analysis, frequency domain, time frequency, or in system analysis. And then we can not only know the gearbox fault conditions, but also actually diagnose and find out the real cause of the fault in a gearbox. Thank you.